Hello, welcome to everyone in this video. This is lecture number 12 on digital electronics. Today we want to discuss about the register. Among these registers, we will actually discuss about shift register, that is serial in, serial out, then serial in, parallel out, then parallel in, serial out, then parallel in, parallel out, shift register. We will be discuss up to 4 bits. You can see this is the syllabus, integrated circuit, number system, digital circuit, then implementation of different circuit, data processing circuit already covered. In the last section we discussed about sequential circuit. Today we want to cover this register part. In upcoming session we will be cover counter, computer organization and data conversion. So let's start today's discussion, that is the shift register. What do you mean by shift register? Actually, shift register is nothing but a digital circuit. You can see this is a digital circuit using cascade means one by one cascade of flip flop to shift the data. Cascade means this is a flip flop 1, this is a flip flop 2, flip flop 3. Its output is the input of next, its output is input of next. It's like that. This is called a shift register. Okay, if you want to know about the application of shift register, actually the adder adder and adder and subtractor. From the adder you get the addition, subtraction you get subtraction. What about multiplication multiplication and division? You can say if you add it many times you will be get multiplication, and if you subtract many times you will be divided. Subtract many times. Suppose you wants to find 2 multiplied by 3 6, you can add 2 in 3 times, you will be get the same result, like that. But many times addition gives you a complex circuit, or there is a time delay and complicated, right? Complicated. So avoid these things, you use shift register. So shift register actually used for multiplication, multiplication and division. You use shift register for multiplication and division. Okay. For example, suppose left shifting. We take an example of 4 bit 0001. The value is 1. If you shift it towards left, you will be get this is 2. If you shift it left, you will be get 4. If you shift it left, the value of this is 8. So this is nothing but multiplication by 2. Multiplication by 2. For right shifting, okay. Suppose you shift in towards the right. This is 8. Right shifting will be get 4. Right shifting will be get 2. Again right shifting will be get 1. So this is nothing but the division by 2. So shift register is used for multiplication and division. I think clear about the shift register, its definition, application, etc. There are types of shift register. You can see types of shift register. There are four types of shift register, that is serial in, serial out, SI, SO. Serial in, serial out means actually here use D flip flop. Here, okay, I just write down serial in, parallel out, serial in, parallel out. Then parallel in, serial out, serial out, parallel in, serial out, and then parallel in, parallel out, parallel in, parallel. These four type of shift register actually made by D type flip flop. D type flip flop. You know D type flip flop, that is SR flip flop are connected by a NOT gate, and you know this QN bar. You know the output to table of D flip flop is like that, D, and this is QN plus 1. When this is 0, this is Q 0. Actually clock is 1, and 1, this is 1. So this is just store the data. Store the data. So that's why D type flip flop used in shift register. Okay. Now we discuss wants to discuss this four type shift register in detail. First one is the serial in, serial out. So we take 4 bit. So you take D type flip flop. This is D3 and its output Q3. Towards next flip flop, it is D2, its output Q2. Next D type flip flop, uh, D1, this is Q1. Next D0, Q0. Okay, this is flip flop 1, flip flop 2, or even reverse. This is flip flop 3, this is flip flop 2, this is flip flop 1, flip flop. Okay, no problem. 1, 2, 3, 4, etc. And there is a clock pulse. All are connected with a single clock pulse, and you know the notation, uh, trigger notation, that is the H trigger clock pulse. Okay. Now you have four inputs. They are serially input. They are serially input, and the output taken serially. Okay, the output taken serially. There is a preset and set connector. You can just add them in preset and set position. Okay, just you want to draw the basic diagram. For practical purpose, you need to add it. There is a preset and there is a clear button also, and you know the preset clear in the previous lecture we discussed. So we just for basic understanding we just draw this and suppose so there is 4 bit Q3, 4 bit. So at the initial Q3, Q2, Q1, Q0, at the initial all are 0. You have a 4 bit. Suppose 4 bit is like that, 1 1 1 1. Okay, when clock pulse 1 is passes, clock pulse 1 is passes, you know the D is 0, Qn plus 1 0, D is 1, Qn plus 1 is 1. So one single clock pulse passes, so this input go to this output, that is this one go to Q1, Q3, and rest are 0. For second clock pulse, next one is come to here, and this is since 1, so this will becomes 1. Okay, this will become 0. For next clock pulse, this one go to this one, and this one go to that one, and this one will gives you Q3 here. For next, this one comes to here. So 4 bits are loading. So all the 4s are bits loading. So for loading, the clock pulse required 4. Here the 4 bit for 4, and the Q0 already read this one. For read next, you need to one clock pulse to read that one, and during that this shift here, then this shift here. For next clock pulse, this actually given here, and for next clock pulse this is. So another 3 clock pulse you require to reading. So for reading, your clock pulse required 3. So finally you can say total clock pulse required is 7, right? For n bit, you can see this is n, this is n minus 1, so their summation will be get 2n minus 1. So for n bit you require 2n minus 1 clock pulse. Okay. For n bit you require 2n minus 1 clock pulse, and here this input and output taken here. So serially in and serially out. This is the shift register, serial in, serial out. Next is the serial in, parallel out. So you just take the serial in. So I just take the copy from here. Just copy paste serial in, parallel out, right? Serial in, parallel out. Okay. See. I can copy this and paste here also. Paste here also. Okay. Now serial in, parallel out. So they are int from here. Our example was taken 4 bit, that is 1 1 1 1. So first one, so this is Q3, Q3, Q2, Q0, Q1, Q0, Q1, Q0. When this at initial all are 0, and parallel out means taken out from the each point. So this is out. When clock pulse 1 is processed, this one shifted from that one. So Q3 1, these are 0. When clocks 2 are processed, this one become go to that one, and previous one. 3 and 4. You can see for loading you need 4 clock pulse. For reading you does not require any clock pulse, because when clock pulse 4 here, all are inputs are present here, parallelly outputted. So for n bits, this is in, this is 0. So total clock pulse required, you can say that is n. For n bit, for 4 bit, this will be the 4 clock pulse required. Clear? Next is parallel in, serial out. Parallel in means inputs will be like that. This is in, this is in, this is in, this is in, this is in input, this is input, this is input, and serially out. Out. Okay. So you just think uh, that is um, you have 4 bit, you have 4 bit, that is 1111, and parallel in means with a single SL. So if you 4 bits, that is inputted here in parallel. Parallel means with a single clock all are setted here, with a single clock all are loading, with a single clock all are loading. So for loading you need 4 bit, that is sorry, single clock. But if you get output, so one output here, but this output required another clock, for another clock this will, and for another clock this will. So you required n minus 1. For reading you required here 3, that is n minus 1. So total clock pulse required is nothing but, that is 1 and n plus 1. So their summation will be n. Clear? And another thing is the parallel in, parallel out. So this is in, this is in, this is in, this is in, this is input, this is input, this is input. These 4 are inputs, and output are here also parallel, output also parallel. So if you have 4 inputs, 4 bit, so inputs for a single clock all are inputted here, q3, q2, q1, q0, all are inputted here, and after just clock this one you get output also. So for loading you require 1, and for reading you does not require any clock pulse. So finally you will be get single clock pulse. Total clock pulse required, clock pulse required is 1. So this is the basic of 4 type of shift register. Okay, so I think clear about the total number of clock pulse required. It is important, and for your information, that is I want to say there is a preset and clear uh, inputs also here, but I, for simplification, I did not include them here. Okay, so that's it for today. Thank you.